Hello, my name is Ash. You must have come from the infographic. Today I will explain machine learning methods in predicting ncRNA-protein interactions. But before that, what are data sources and how are the performance evaluated? Machine learning utilizes ncRNA-protein databases for data-driven decisions. The databases established are RPI 488, RPI 2241, Piner v2.0, and RAID v2.0. For the performance evaluation, the most commonly used are leave one out cross-validation LUC and k-fold cross-validation KCV. In the article, cross-validation is used to obtain the area under receiver operator characteristics for performance evaluation OC. There are 9 computational models for prediction. The first method is IP-Miner, which stands for Interaction Pattern Miner, and it is related in discovering hidden sequential interaction patterns from protein and RNA sequence composition characteristics using stacked autoencoder. Then, the original features are inserted into the stacked autoencoded for RNA and protein. Before fine-tuning, it will be converted into high-level features SDA, but after fine-tuning, it will turn into high-level features SDA-FT. Original feature, high-level features SDA and high-level features SDA-FT will get into RF classifier and changed into RPI-seq RF, SDA-RF, and SDA-TF-RF respectively. Lastly, the 3 of them will turn into logistic regression. The second method is LPI-PPSN, which will predict the long non-coding RNA to protein interactions by combining 4 protein-protein similarity networks. It starts with several protein sequences that have been constructed into protein-protein similarity networks PPSN. Then, the PPSN will employ a similarity network fusion SNF algorithm to convert into fused PPSN. With an additional reaction from known ncRNA-protein interaction, fused PPSN will use the Hedesum algorithm to check for the protein similarity interactions. PLPIHS is the third method used in this article. This computational model will use Hedesum score in order to predict ncRNA-protein interactions. With the combination of several ncRNA and protein networks, a heterogeneous network is formed. By using Hedesum score, the SVM classifier can at last be used in order to predict the ncRNA-protein interactions. HLPI ensembles can also be used in order to employ an integration strategy of SVM, RF, and XGB to generate their ensembles. There are several ncRNA features that can be used in this model based on its algorithm, such as CHIMER, DSC, PCP, SEDNC General, AC, and PCP, SEAAC General. The performance indicator for this model is based on the AUC value of HLPI SVM ensemble, HLPI RF ensemble, and HLPI XGB ensemble. Next is our PISAN models, which use stacking autoencoder networks to mine hidden high-level features of ncRNA and protein sequence. It utilizes a specific scoring matrix PSSM and K-metasparse matrix to extract features of protein and RNS. The SAN will be processed only after protein and RNA features are in vectors format, conjoined with our F classifier to infer potential ncRNA-protein interactions. Hypothesis of LPGNMF is similar LNCRNA likely to interact with the same protein. Through this model, unobserved LNCRNA interaction can be found. Each input of this model will undergo matrix decomposition, which consists of similarity matrix and sparse similarity matrix. In the last step, the ncRNA protein apply the graph regularized non-negative matrix factorization to predict the interaction matrix. The 7th model is a sequence-based approach, BGFE, that also uses SAN and RF classifiers. It starts by employing K-MERS sparse matrix to represent ncRNA sequence and PSSM to represent protein sequence. The feature vectors extracted will undergo a stacked autoencoder network before fused into an RF classifier. The next method is RPISE, a stacking ensemble computational method such as XGBoost, SVM, and XtraTree. It begins by applying K-MER to extract ncRNA sequences and position weight matrix PWM. It then exploits a stacking ensemble computational method framework which consists of the 3 machine learning classifiers to produce a stacked ensemble. Lastly, the model LPIMMHN works based on the hypothesis ncRNA and protein interact when sharing common mRNAs. mRNA acts as mediators in heterogeneous networks. The common mRNA undergoes matrix association, while mRNA association network undergoes in 3 different ways, including network similarity, sequence similarity, and statistical features similarity. The final 3 inputs then undergo the final scoring matrix. That's all for this video. Thank you.